Hi everyone. Today we are going to discuss on a topic transportation model. This transportation model I'm planning to take in two parts. The first part we will discuss the following headings: introduction, mathematical model of transportation problem, the transportation algorithm, and methods of finding initial solution. We know transportation model is a special case of linear programming model, mainly associated with logistics. Transportation problems deal with the transportation of a product manufactured at different plants to a number of different warehouses. The objective is to determine optimum shipping routes between supply centers and demand centers in order to satisfy the required quantity of goods at each destination center with available quantity of goods at each supply center at the minimum transportation cost or time. General mathematical model of transportation problem can be seen like this. It will be represented like a table like this. In this table you just see these are the sources S1, S2, etc. up to Sm sources. Suppose we have M sources, and D1, D2, etc. up to Dn are different destinations. For each destination, then we will have that much number of routes, number of sources into number of destinations, that much routes will be there. Each route will be associated with some cost part. For example, from source 1, first source to first destination, the cost of transporting a single product is C11. And suppose we are going to transport a particular number. For the time being we will name it as the decision variable like x11. X11 units we will transport from S1 to D1. Then the total transportation cost for this route will be C11 into X11. Like this we will represent the entire transportation problem. And in the last column you just see the supply. For each source it will be able to supply a particular number of products, that is A1 is corresponding to S1. Similarly, these columns are representing the supply part. And the last row you can see it's a demand part. For each, suppose it's a destination center or if it is a warehouse, then it will require some demands. There will be some demands. So this can be represented like this. And the last cell you can see the sum of all the supply will be equal to the sum of all the demands. This is a case of balanced transportation problem. Basic assumptions in transportation model. Total quantity available for distribution is equal to total requirement in different destinations together. Another point is that the unit transportation cost from one origin to one destination is certain. The unit cost is independent of the quantity transported, and our overall objective is to minimize the total transportation cost. Some points to be noted here. When the total supply is equal to total demand, then we will call the transportation problem as a balanced transportation problem, also known as a rim condition. Otherwise it is known as unbalanced transportation problem. The unbalanced transportation problem can be made balanced by adding sufficient rows or columns. We will call it as dummy rows or dummy columns. And when the number of positive allocations at any stage of the feasible solution is less than the required number, in any transportation problem, the required number of allocations or allotment should be number of rows plus number of columns minus 1. the solution is said to be degenerate. Otherwise, we will call it as a non-degenerate. And cells in the transportation table having positive allocations, that is the value are greater than 0, are called occupied cells. Otherwise, we will call it as unoccupied cell or empty cells. Mathematical model of transportation problem we will understand with the help of the following example. Clearly understand the question. A company has 3 production facilities, F1, F2, F3, with production capacities 7, 9 and 18 units per week of a product respectively. These units are to be shipped to 4 warehouses, W1, W2, W3 and W4, with requirements 5, 8, 7 and 14 units per week respectively. The transportation cost in rupees per unit between factories to warehouses are given in the following table. Formulate this transportation problem as a linear programming model to minimize the total transportation cost. This is the transportation matrix, general mathematical representation. In the first case, we will have to check whether the total supply is equal to total demand. Then only it will be a balanced transportation problem. Otherwise, we will make it into a balanced transportation problem by adding sufficient rows or columns. So just add 5 plus 8 plus 7 plus 14, that is equal to 34. Correct. Supply is also 7 plus 9 plus 18 is equal to 34. So this is a balanced transportation model. And we have 3 factories, F1, F2, F3, 4 warehouses, W1, W2, W3 and W4. You can easily see here. And these numbers are the transportation cost. From factory 1 to warehouse 1, the cost of transporting a single product is 19 rupees. So here we want to formulate this problem as a linear programming model. By looking into this table, we can easily understand that there are 3 factories and 4 warehouses. So automatically we will get 3 into 4. There will be 12 routes. In order to represent this as a linear programming problem, we will understand that we know that there will be 12 decision variables. X11, the number of units of transporting product from first factory to first warehouse, that is X11. So similarly, we will have all these routes will have separate decision variables. We can commonly name it as Xij, the number of units of products to be transported from a production facility. In this case, we have 3 facilities to a warehouse. We have 4 warehouses. And then we will take the objective function. The objective function, our aim is to minimize the total transportation cost. So minimize Z equal to 19x11 plus 30x12 plus 50x13 plus 10x14 plus 70x21 plus 30x22 plus 40x23 plus 60x24 plus 40x31 plus 8x32 plus 70x33 plus 20x34. Subject to the constraints, supply constraints are there, demand constraints are there. By taking into consideration of this, we will get x11 plus x12 plus x13 plus x14. They are supply constraints is equal to 7. Similarly, x21 plus x22 plus x23 plus x24 equal to 9. X31 plus x32 plus x33 plus x34 equal to 18. And for the demand constraints, x11 plus x21 plus x31 equal to 5, x12 plus x22 plus x32 equal to 8, x13 plus x23 plus x33 equal to 7, x14 plus x24 plus x34 equal to 14. And last, the non-negativity constraints, all xij values should be greater than or equal to 0. The transportation algorithm, we have 4 steps. The first step, we will formulate the given problem and arrange the data in a matrix form. Second step, obtain an initial basic feasible solution by any one of the following methods. We have three methods to calculate the initial basic feasible solution. They are northwest corner method, least cost method, and Vogel's approximation method, also known as penalty method. This initial solution obtained, it must satisfy the following conditions. The solution must be feasible, that is the rim condition, first thing, and the number of positive allocations must be equal to number of rows plus number of columns minus 1. Step 3, test the initial solution obtained in step 2 for optimality by modified distribution method. If the solution is optimal, then stop, otherwise determine a new improved solution. Step 4, updating the solution. Repeat step 3 until an optimum solution is reached. Now we will discuss how to calculate the initial basic feasible solution by these three methods: northwest corner method, least cost method, and Vogel's approximation method. First one, northwest corner method. The algorithm for this method is like this. Select the northwest corner of the table and allocate the maximum possible units between the supply and demand requirements. During the allocation, transportation cost is completely discarded. We will not take into its consideration. Second step is delete the row or column which has no values for supply or demand. Now with the new reduced table, again select the northwest corner cell and allocate the available values. Repeat the steps 2 and 3 until all supply and demand values are 0. Obtain the initial basic feasible solution. This algorithm we will test with the help of the same question. So by looking into the transportation matrix, first step is we will focus into the northwest corner cell. This is the first cell. And by looking into the supply quantity and the demand quantity, we will allocate maximum in this cell. In this particular case, we can see that the factory can supply 7 products. At the same time, the first warehouse require only 5 units. So we will allocate this 5 units here. So what will happen? This demand part will be exhausted, completed, and supplies part, this 7 will be reduced into, there will be a remaining 2 units. So we will keep that part there, but at the same time we will close this column of the table for the next step. Now we have the remaining portion like this. So focus here also into the northwest corner. So the first cell will be there. Here we will look into the factory will be able to supply 2 units. At the same time the warehouse require 8 units. So we can supply a maximum of 2. That we have arranged here. 2 will be allocated here, and so this will be over, this will be exhausted, and the remaining 6 units will be there. Automatically this row will be removed from the table. We'll go for the next allocation. Now this is the remaining part. The northwest corner will be this cell. So try to allocate maximum in this cell. The warehouse requires 6 units and we have a supply of 9 units. No issues. So we will give that 6 units here and fill this unit, and this column will be removed. So we have the remaining portion like this. This is the northwest corner, and we will allocate. Factory has a capacity to supply 3 units and we require 7 units. So we will supply this 3 units here. So it will be come over, and remaining 4 units should be required for the warehouse, and this row will be removed, and then the last this much portion will be remaining. Northwest corner is this much, this cell. So allocate this 4 here, and it will be completed, and the remaining 14 will be there. That 14 we will allocate in the last cell. So the allocation is over. Now you just count how much allocation, number of allocations we have done with these much cells. 1, 2, 3, 4, 5 and 6 cells we have allocated. We called it as occupied cells. Okay, so this is a initial basic feasible solution by the method of northwest corner, and we have to calculate the total transportation cost in this case. So just calculate 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20. The sum is equal to 1015 rupees is there. This is the northwest corner method, and just note this amount. This is 1015. Now we are moving to the least cost method. The algorithm goes like this. Select the smallest transportation cell cost cell available in the entire table and allocate the supply and demand. Delete the row or column which has exhausted. The deleted row or column must not be considered for further allocation. Again select the smallest cost cell in the existing table and allocate. Obtain the initial basic feasible solution. This is the original transportation matrix. Here in this case this is a least cost method. So attention should go first into the least cost of all the cost elements. So we have seen this 8 is the least cost. So in this cell we are trying to allocate maximum. So the demand is 8 and the supply is 18. So we will allocate this 8 here. So remaining 10 will be there. Then we will move into the next least cost. So by looking into here, we can see that this is the next least cost 10. So here the supply is 7 and demand is 14. So we can easily supply that. This 7 is allocated here. So there will be a remaining 7 for this warehouse. Now goes to the next least cost, that is here the amount is 20. So we will allocate this 7 and 10 is there. So we will allocate the 7 here, and in this part there will be a remaining element of 3 units. Cell is over, and in this cell is also over, and here also it's over, exhausted all these things. Now the remaining values are 40, 40, 70, 70. The minimum cost is 40 and 40. So first we will focus into the cell which in that we can give maximum, or we can allocate maximum quantity. So this 40, this cell we will focus. So we need this warehouse requires 7 units, we can supply 9 units. So we will allocate this 7 here, remaining 2 is there. Or this column has been exhausted. Now remaining these 2 values, of which the least cost is 40, we will allocate this 3 here, and we have a requirement of 5, so balance 2. This 2 will be allocated to this column. So we will allocate like this. These two are cancelled, and it will be allocated to here. Now also you just see how many occupied cells are there. 1, 2, 3, 4, 5, 6. For recognizing these cells, I have given different colors. So it is very easy for you to understand. There are 6 occupied cells. Now our condition is okay. One condition. Second condition is that we have already checked total supply is equal to total demand. So this is also an initial basic solution. And now we have to calculate the total transportation cost 2 into 70 plus 3 into 40 plus 8 into 8 plus 7 into 40 plus 7 into 10 plus 7 into 20, which is equal to 814. You just compare the earlier value with this. By comparing with the northwest corner method, least cost method is far better. Now we will look into the Vogel's approximation method, VAM method, also known as penalty methods. Here we will calculate penalties for each row and column by taking the difference between the smallest cost and the next highest cost available in that particular row or column. If there are two smallest costs, then the penalty is 0. Select the column or row which has the largest penalty and make allocation in that cell having the least cost in the selected row or column. If two or more equal penalties are exist, select one where a row or column contains minimum unit cost. If there is also again a tie is there, then select one where maximum allocation can be made. Delete the row or column which has satisfied the supply and demand. Repeat the steps again and again until the entire supply and demands are satisfied. Obtain the initial basic feasible solution. In order to understand the algorithm of Vogel's approximation method, we will take the following example. We are using the same question here also. In this case, we have introduced a new column row differences and a new row here, that is column differences, in order to calculate the penalty for each time. So in this case, in order to calculate the penalty, we will take for each row, take the first row, the least cost is 10 and the next highest cost in this case is 19. Take the difference of these two, that is the 9. This is that value. Similarly, the second row, you can have the minimum value is 30 and the next highest value is 40, so the difference is 10. That is the penalty. In the third row, the least cost is 8 and the next highest cost is 20, so the difference is 20 minus 8 is 12. This is the row wise penalty. The same way we will calculate the column wise penalty also. And don't take the demand and the supply, they are units, they are not the cost element. So only the cost elements we will calculate. So here in the first column, the least cost is 19, the next highest cost is 40, so the difference is 21. In the second column, least cost is 8 and the next highest cost is 30, so the difference is 22. Here least cost is 40, next highest cost is 50, difference is 10. Here the least cost is 10 and the next highest cost is 20, difference is 10. Of all these penalty values, we can see that this 22 is the highest penalty. So we will look into this column and the least cost is 8. Here we will allocate maximum possible units. So here we will check this warehouse demand is 8 and the supply of this factory can supply 18 units. So it is easy to allocate 8 units there and remaining 10 we will put here. This 8 units will be exhausted, so it will be allocated here. So the column will be removed for the next iteration. The next, again we will calculate the remaining values, cost elements, by taking the raw difference like 10 and 19, difference is 9. Again here least cost is 40 and next highest cost is 60. Take the difference as 20. In this case least cost is 20 and the next highest cost is 40, so the difference is 20. In the column wise 19 and 40, the difference is 21. Here it won't be there for this time because all these elements these units have been exhausted. And here The least cost is 40 and next highest cost is 50, so difference is 10. Here least cost is 10 and the next highest cost is 20, so difference is 10. So of all these penalties, the second time we can see that this is the highest penalty, 21. So we will look into this column and look into the least cost element. Here we will allocate maximum. In this cell we will try to allocate maximum units. So the demand is 5 and supply is 7. So we will fulfill this demand here, and there will be a balance of 2 units. Automatically this column will be removed for the next stage. So we have this much cost elements. Calculate the row difference penalty again. 10 and 50 difference is 40. 40 and 60 difference is 20. 20 and 70 difference is 50. Here there is no elements. Here 40 and 50 difference is 10. 10 and 20 difference is 10. So the highest penalty value is 50. So we'll look into this row and allocate into the least cost element, the least cost cell. We can allocate this 10 here, and remaining of the 14 there will be a shortage of 4 units that we will put it here, and along with this row has been removed. Now we have the following this much area. Take the difference, 10 and 50 difference is 40. 40 and 60 difference is 20. Here difference is 10. Here difference is 50. Now again look into the cost element. This is the highest penalty value. So we will look into this area, this column. Least cost is 10. There is a supply of 2 and requirement of 4. So we can easily supply this item here. The balance will be 2 and this row will be removed. Now we have only these 2 elements. Looking into this, you see the least cost 40 here. You can supply maximum here. 7 you can supply, balance 2. These 2 you can supply to this 60 cost. Thereby we have done all the allocations. Now we can calculate the total transportation. Before going to that, now we can calculate the total transportation cost. 5 into 19 plus 8 into 8 plus 7 into 40 plus 2 into 10 plus 2 into 20 60 plus 10 into 20. The total transportation cost is equal to 779 rupees. And also you can count the number of allocations, 1, 2, 3, 4, 5 and 6. That should be there, because number of columns plus number of rows minus 1 should be the number of occupied cells. Here we got that. So this is an initial basic feasible solution by Vogel's approximation method. Hope you understood this. Thank you.